Good afternoon. So I'm going to cover several different technologies here pretty quickly, um, which is kind of across many different areas. So Oceanit is a locally based company here in Hawaii, about 160 engineers and scientists, offices in different places, but headquarters here in Hawaii. And our customers primarily hire us to do breakthroughs. We just have a diversity of people, and that's kind of the area we focus in. Four major areas, including life sciences, engineering, space, defense, information systems. Today, we spend a lot of our time kind of working in this space of disruption to kind of cause disruption. There are kind of three major ways we kind of operate as a company, but the only thing I'm going to really mention anything was about this kind of transdisciplinary organization, which kind of explains how we're able to do what we do. So most organizations are kind of built around making it easier to manage, but in the process, it makes it difficult to innovate. So at our organization, we're kind of mixed up. We definitely work across groups. So we're built to innovate, so it's actually a little bit more difficult to manage at times. But you come up with crazy ideas. So one thing that we've been working on is we call it anti-ice, and it's actually a next generation anti-icing coating. So equipment, exteriors, interiors of equipment, icing becomes a big issue. It affects performance, also creates safety issues, safety hazards, just maintenance costs. So what we've been developing, and actually the US Army did the testing recently of our material called anti-ice. And the best performing some of these things is like Teflon, but this new coating that we developed is about 46 times better than Teflon. In fact, when the US Army was doing the testing, they actually had to change their test methods because they couldn't measure the performance. So it's about 5.1 kilopascals for the ice adhesion strength test. In many ways, what we're doing is we're just mimicking nature. So a lotus leaf is very hydrophobic. So very similarly, we're doing that. But what's a little bit different is most of these coatings are temporary. So we do have a spray-on coating that's temporary, but the major innovation was to develop a permanent coating. So we literally changed the surface morphology to make these super hydrophobic coatings. So the temperature operating ranges actually is currently is limited by our testing equipment. So minus 80 Celsius to 200 Celsius, and it's super hydrophobic. So the contact angles are over 170 degrees. Let's see. And if you play this, I think there's a video clip here. And I don't know if you can play that, but that'll just show you a little test we did in the office. So you have an uncoated metal surface, an epoxy-coated metal surface, and then our ice-phobic coated metal. In fact, it's hard to actually get the beads of water to stay on the surface. Besides, one of the things that we're noticing, besides the anti-icing capabilities of this material, is as a coating for electronics, to prevent corrosion. Here in Hawaii, we have extreme corrosion problems. Nothing seems to really work very well. So we're actually coating electronics, internal electronics, to actually keep out moisture, and because nothing can really adhere. Even the moist air can't really get into the material. So this is actually an aluminum test strips. So the one on the left is just bare aluminum, and the one on the right is coated with our super hydrophobic coating. So this is after 3,000 hours in our fog chamber. And so actually here at the hotel, we work with the hotel folks here. So we're actually, after this session, I'm actually picking up a point of sale register, a computer register from them that after 2 or 3 months just corrodes out from because it's up by the near the beach. So we're going to be coating one of their terminals for them. Okay, the next technology we call dry SAF. So it's a passive boot drying system. So has anybody ever gone like hiking in, and got your feet wet, and after a day, your feet kind of looks like this, and it's pretty gross. It's pretty painful. I mean, that's just a day, right? But imagine if you're in cold climates, hypothermia. There's all these other kinds of challenges you face. But when you're in the field, and you have 1,000 guys in the field, you can't say, hey, let's make fires, and there's no use, you can't use energy, you can't do anything, so you're pretty much suffering out there. So how do you dry boots passively? And so currently the state of the art is, you have actual boot drying dryers, you have dry warmers you stick in the boot, there's even a heated boot bag. You can take your wet boots, put it in a boot bag. You can even wrap your boots in different things, chemical heat, but in the process you damage your equipment. And they all require power. And the problem is when you're in the field and you got a lot of guys, you don't have power. I know people take newspaper and they stuff newspaper in their boots, but even that, you're going to carry around newspaper. So what we developed, have been developing is a process and a material. So this is actually a shop towel that we basically treated. So we invented a new kind of material. We can actually coat anything, and so we're actually coating like some dry material, kind of dry fit materials. But the current technology, you stuff it in the boot, and in about 6 hours it gets the boot dry to the touch. It's designed to be reusable, multiple reuses. It's antimicrobial. It's also disposable and low cost. So the whole idea is you can reuse this thing and then eventually just throw it away. It's lightweight. There's no power required. And there's multiple applications for a technology like this, not just drying your boots. So here's an example. The picture on the left on the top is actually fabric coming off our system. The bottom is actually the actual machine that makes it, and the right side is one of the boots as a display. The other thing is, when you have wet boots, that means you got wet socks, and you got wet equipment. So I'll let these. Our sessions will begin again in about 5 minutes. So you can use this material, and we've been using it to dry socks, besides not just the shoes, but socks, gloves, even shirts. So you could take a wet shirt, roll it up in this material, and in 1 hour the shirt will be dry. So any equipment that you get wet, you can dry it with this material. And then again, it's because of the way it's designed, it actually dries, by the next day, this material will dry, so you can reuse it. Now, the next technology is all around plating. So we have, as you can see, we have this advanced materials group, so we do a lot of interesting things here. So we have a thing we call soap, and it's basically a new type of brush plating, electroplating methods. So the traditional method is you electrify the surface, you have a brush, you have a liquid, and you basically rub it on a surface and it deposits metals. It's a lot of science, but it's a lot of art too. It actually takes a lot of skill to do it, but it's also very messy and there's a lot of waste. And so it's not very portable as well. So what we developed was this thing we call soap. So there's a reduction in the waste. There's no need for recirculation of chemicals. And really, in some ways, you only need water to activate the system. If you electrify the surface, you get deeper, you get more deposits of metals that can form, but you can also do it with just water. So we essentially took a liquid, the electrolyte, this liquid that has the metals in it, and actually made it into a solid. So think of it like when we think of soap, I think of soap on a stick. So basically, we can make these solid forms and basically so you can actually take it to the field. So electroplating doesn't have to go to where the equipment. A lot of times the equipment has to go to a certain place for doing the electroplating. Now you can actually do it in the field. And we can actually make these pieces into different shapes, sizes, We can actually add different kinds of metals. So, nickel, copper, zinc, and even chrome. And these are some of the features of it. But essentially, you're making something that's a liquid into a solid. So you can take it to the field and actually repair equipment, coat equipment, gun barrels, or whatever you need to electroplate. You can do it in the field. And we can shape it into any size and shape you want. The next one is around medical. So we've been developing something we call DIRT. It's a faster, safer blood clotting admixture. So a lot of different technologies out there. About 90% of combat casualties actually happen in the field before the guys ever get back to a medical facility. So managing hemorrhaging in the field is critical, and so there's a lot of different technologies out there. And so we've been working on something we call DIRT. It actually is an acronym. But it's really a combination of two different materials, FDA-approved materials, but adding kind of the nanoscience behind it. So we're creating a larger surface area around a particular material and then blending it together to create this kind of nice polymer mixture that actually performs extremely well. So in terms of compact gauze and some of the other products out there, we actually are almost instantaneous in actually stopping the bleeding and doing it safer without a lot of pain or injury to the soldier. The next one is hearing protection, so passive hearing protection. So the number one claim today, I think, is around hearing loss in the military. In 2009, the VA paid out over $1 billion in hearing loss claims. But the trick is, how do you provide hearing protection without losing situational awareness? Because a lot of times when you put a hearing earplug in your ear, you're basically blocking out all the noise. So the trick is, how do you still provide situational awareness? Still you're able to hear, but when there's loud gunshots or loud sounds, you actually filter it out. So there's a bunch of different technologies out there today. But the main thing is, when you actually put these things in, they actually have, they actually will block out some of the sound. And that is actually really kind of important, because when you start having any kind of hearing loss because of any kind of hearing protection you put in your ear, it affects your response. So it's like, I don't know if you've ever been in a room and it's super noisy and you can't hear, and somebody says something to you, you're gonna pause because you're still trying to process what's going on. So if I have anything in my ear that is filtering out any noise, even if somebody is walking up behind me, I will hear that in there'll be a delayed response, and that's kind of dangerous for, of course, your situational awareness. So the technology we're developing has virtually zero insertion loss, what they call zero insertion loss. So basically when you put it in, you can still hear all the conversations, you can hear everything, but when there is a gunshot or a loud noise, it actually will filter it out up to 30 dB. So it's a combination of design and some materials put together in kind of this low-cost, scalable production that we're going to be doing. And we're going to be testing, full testing in June of 2015. And actually, that's it. That's a real quick, blasted through, high-level,
okay, but
get you out of here.
But yeah, we're going to get to you some questions, though. So,
sure.
And I really appreciate you filling in. 5 technologies in less than 15 minutes. So we have to go back 1 through 5. And I just to remind everybody what the order is. In fact, I don't even remember the order. You went from the ice, then to the electroplating, then the passive drying, the hearing protection, and the wound protection. So let's take all 5 of them. Are they currently being funded by DoD entities?
Yes.
Okay. And are the TRL levels?
They vary. Like this particular product, like the soap product is actually a pretty high TRL. It's probably around a 7, 8 at this point. We could fund it from the Navy side. So actually the base commander at the Naval Shipyard. And this is the challenge for the guys in R&D like us. So we listen, we go see what they're doing, we invent these technologies, but now we have the struggle of that transition.
Okay.
Because sometimes these things are so new that there's no requirement for them.
Right.
So that the acquisition folks are saying, well, I have a requirement that says I can buy red shoes, but you've invented a blue shoe. How do I do this thing? And so a lot of times what I'm doing is on the commercial side is finding, okay, where do I find commercial markets for some of these technologies? The boot drying technology is a phase 2 SBIR. We're actually, the thing that I didn't show was we're actually having to build the machine to actually make this stuff, because there's no machine that's invented to do it. So we're literally designing and building a machine. We're shipping it to Hawaii so that we can start producing thousands of these for trials with the Marines.
Okay.
The U.S. Marines, yeah. But then we're working with commercial. We're meeting with Nike and
Under
all of these
Armour.
Under Armour, Cascade Designs, all of these outdoor companies that are saying, wow, this should be a great boot drying, ski drying, boot drying
Right.
technology for the commercial markets.
So the biggest thing is you're funded up through the development, transition,
And then
And-
trying to find a DoD
Right.
transition
Okay.
a lot of times is
or
the
whether
struggle.
it's from a production standpoint, you would license the technology or partner with the production.
So depending on it, a lot of it will be licensing to strategic partners
Okay.
like Cascade Design that
Right.
already manufactures drying towels, like for camping, but they're not disposable, right?
And how far along are you on the hemostatic wound?
The hemostatic one is pretty new. It's pretty low. The TRL is still around probably a 4.
Okay.
They're just gonna start small animal trials, so it's pretty still in early development.
DoD Surgeon General or?
Through
He's-
Army Medical Research.
okay.
Yeah,
Okay.
a lot of that is through that. And then what is the other ones I was talking about?
The plating,
The
char deck.
plating, the anti-icing. The anti-icing is actually closer to an 8. So actually, originally kind of in development for Air Force heat exchangers.
Right.
Heat exchangers start icing over, performance gets affected. So these things help to prevent icing from occurring. But there's a lot of other applications. So
What about performance? Like so on the electronic side, antennas I see as a potential.
Oh, I never thought about the
Right.
antennas.
Would it impact performance or?
We don't think so, but we have RF engineers, so we have never, I don't think, ever tested coating the antennas with these things.
So
but-
you're aware that the PACOM includes Alaska. So
Oh.
so the whole PACOM environment, and as it
Right.
was briefed to this earlier today, it goes from the penguins to the polar bears, or polar bears to the penguins.
Right.
And I think General Shields is here, and he's got the Army Alaska Command.
Oh, okay, fantastic.
And I know he has issues with icing, so we could
Yep.
probably do an introduction.
Yes, sir.
Yeah, I actually had a question. Unfortunately, I came in kind of a little bit late, but as I understand it, you had a coating that sort of is anti-ice.
Yes.
Can that be used potentially on, say, wing surfaces of UAVs?
Absolutely. What's interesting is the guys have developed 2 versions of this coating. One is a spray-on that's not permanent. So we're testing it out even on electronics, as I mentioned. I've sprayed paper towels, but you could spray this on, and it was brought up before to us about icing on wings. But for whatever reason, I don't think we've ever really kind of explored that area. So we've primarily been around, actually of all places, the oil and gas industry. But that would probably be a great application. We've just never explored it.
May I volunteer my UAV to be tested?
Absolutely.
All right.
Absolutely. Yeah, we can spray coat it, and there you go. I want to talk to you after too.
Speaking of UAVs,
I want to talk to you after.
are
too.
they optically? Is the coating optically transparent?
So we recently did a test for a major glass manufacturer, automotive glass manufacturer, because it was interesting. They wanted a super hydrophobic coating for their, I think, windshields or some other things, and so we did some initial tests. So there's about a 5% impact on the light. But again, that wasn't optimized. That was like a quick, really like, give us a glass. We're gonna take an existing coating that we have. We're gonna treat it, and then give it back to you.
Spectrum, or
Yeah, I
that
think
5% was across the
I
entire
think it was
spectrum?
across the entire spectrum. But again, I think we'd have to I have to go back and talk to our guys. But
Okay.
it was something like 5. There was a 5% impact on the light.
Hmm.
Yeah, but the spectrum, there may have been different wavelengths that may have been impacted. But as you know, a lot of hydrophobic coatings have a little bit of a whitish kind of impact. So
You said TRL 8 for the anti stuff, right?
yeah, it's very high. Yeah. So, anything else? Any questions?
That's excellent. Thank you so much again.
No, no,
I
thank
really
you so much.
appreciate you
Thank
filling
you.
in. And just a reminder, and you tell your team back at Oceanit, this will all be, it's all being filmed, and it will be
Okay.
posted on the public site.
Great.
So don't be discouraged, the small audience. We'll see thousands of people will see this.
No problem. Thank you so
Thank you,
much.
sir.
Thank you so much. Thank you.